Ergodic theorem states that for any random process x of t, all time averages of sample function of x of t is equal to ensemble averages, the corresponding ensemble averages of x of t. Okay. So how do we denote sample function? Small x of t we use to denote sample function. Okay. Here what is that? This also we are obtaining from random process x of t. Here what is that we are doing? We are fixing the sample space and varying the time. Fix the sample space, okay, and vary the time. Time is varied. Okay, so like this, by varying, we get the sample function x of t. Okay. Now the time average of sample function is equal to n sample average of random process. Here, see here, capital X of t we use to denote random process, small x of t we use to denote the sample function. Okay. So the time averages of the sample function x of t is equal to n sample averages of the random process x of t, then that particular random process is satisfying Ergodic theorem. Okay. So what is that here? The time average we denote it as a of x of t. We use to denote time average. We write it as x bar is equal to expected value of, that is n sample average of the random process capital X of t. So the x bar is equal to capital X bar. This is first condition. What are the time averages here? Time averages will be having three functions, that is time average function, time autocorrelation function, okay, and time cross correlation function. All these are the three functions. These three functions are called time averages. Okay. So what is the first time average? First time average is x bar is equal to capital X bar. So the second time average function is autocorrelation function. That is Rxx of tau is equal to Rxx of tau. Okay. So this is the symbol we use for time average, time autocorrelation function. This is the symbol we use for ensemble autocorrelation function. Here we are discussing only about one random process. Since we are discussing about one random process, that is why we have to discuss only time average function auto, that is time autocorrelation function. That's all. Okay. Time cross correlation we are not discussing because time cross correlation will require two random process. Okay. So here we are discussing about only one random process. Okay. So what is your Ergodic theorem states that for a random process, if time average of a sample function is equal to n sample average of random process x of t. Okay, that is x bar, small x bar is equal to capital X bar. Time autocorrelation function Rxx of tau is equal to n sample autocorrelation function Rxx of tau. Okay. So that is called Ergodic theorem. What is Ergodic process? You take any random process that satisfies the Ergodic theorem, then that random process is called Ergodic process. The random process which satisfies Ergodic theorem, then that is called Ergodic process. Okay. The analysis of this Ergodic process is complex, and in most physical experiments, in most physical applications, all stationary process. We have discussed stationary process in previous classes. Stationary process is E or ergodic process. All stationary process are ergodic process. Okay. Then we just discuss about what is jointly ergodic process. Jointly means what? We have to consider two random process. Here we will be considering the random process x of t and y of t are the two random process. Okay. From this we are getting two sample functions. That is x small x of t, y of t. Okay. So these two random processes are jointly ergodic. If these random processes are individually ergodic, and what is that? The time cross correlation of these two random processes should be equal to ensemble cross correlation. Okay, these two conditions are satisfied. Then these two random processes are called jointly ergodic random process. What is the condition? This random process is individually ergodic. Means what? Individually ergodic means x bar should be equal to capital X bar. That is time average is equal to ensemble average. Okay. Then y bar, that is time average is equal to ensemble average capital Y bar. The second condition is the time autocorrelation function of x is equal to ensemble autocorrelation function of x. Then the third condition is time autocorrelation of function of y is equal to ensemble autocorrelation function of y. Then the fourth one is it has to satisfy the time cross correlation function, that is Rxy of tau is equal to Rxy of tau. Okay. So if these four conditions are satisfied, then these two random processes, capital X of t and y of t, are called jointly ergodic process. So then we will be discussing what is mean ergodic process. Mean ergodic process. So here we will be discussing only one random process here. So we have to take only one random process. This random process is said to be mean ergodic or ergodic in mean. Only if the time average of sample function, okay, time average of sample function of random process x of t is equal to ensemble average. Okay, so if time average is equal to ensemble average of random process x of t, here we are finding time average of sample function of random process is equal to ensemble average of random process x of t. That is, what is time average? Capital A we use to represent time average. Small x of t we use to represent the sample function is equal to what? E we use to represent the ensemble function, and random process is x of t. So what is x bar is equal to x bar. Okay. So this is mean ergodic process. Then we will discuss what is autocorrelation ergodic process. Okay. Autocorrelation ergodic process is nothing but you take any random process. So we will be taking a random process here. Take a random process x of t whose time average, time autocorrelation function. Time autocorrelation function is equal to ensemble autocorrelation function. Then that particular random process is called autocorrelation ergodic process or ergodic in autocorrelation process. Okay. So what is that here? Autocorrelation only if time autocorrelation function of any sample function x of t. We have to take the sample function x of t, that is Rxx of tau. What is Rxx of tau? A of x of t, x of t plus tau. A of x of t plus tau is equal to what? Here we have to use two lines here. Okay, is equal to Rxx of tau. Okay, what is that Rxx of tau? It is E of the random process we have to consider. Capital X of t, capital X of t plus tau. Okay, capital X of t, capital X of t plus tau. So what is that? Rxx of tau is, it is equal to expected value of capital X of t, capital X of t plus tau. These two are equal. These two are equal, then we call it as autocorrelation ergodic process. Okay. Then we will discuss what is cross correlation ergodic process. Okay. For cross correlation ergodic process. Okay. So what is that here? You take any two. Cross correlation means what? We have to take two random processes, x of t and y of t. So these two random processes are said to be cross correlation ergodic or ergodic in cross correlation only if time cross correlation of the sample function of x of t and y of t is equal to ensemble cross correlation. Okay, that is what is time cross correlation. How do you write it as? We write it as x y of tau is equal to what? A of time average, A of x of t, y of t plus tau. Okay, it is equal to what? Rxy of tau. It is equal to what? It is expected value of capital X of t, y of t plus tau. So, if you take any random process which will satisfy this condition, that is, the time cross correlation function will be equal to ensemble cross correlation function, then those two random processes are said to be cross correlation ergodic process or ergodic in cross correlation.